Hello, everyone. Welcome to another Web3 Builders crowdcast series. I'm Caroline. I'll be your host today. Today we have Taylor and Camille from Soramitsu to give a presentation on their C++ implementations. Just a quick thing about Crowdcaster. You have the chat box on the right. Feel free to use that and get some discussion going. And if you have any questions during this presentation, please use the Ask the Question function at the bottom. There you can vote on your preferred question, like what you want to hear, and Camille and Taylor will come back to them to answer when they're doing their presentation. Cool. I'll hand it over to you, Taylor.
Awesome. Can everybody hear me okay? All right. We already went through the green room, so it seems like I'll be okay. My name's Taylor West, and I am the Chief Strategy Officer at Soramitsu. And I'm not sure how I got roped into doing this crowdcast. I think our CTO wanted to get back at me for something, so here I am. But I'm glad to be here, and I'm excited about the project that we're doing with Web3 and Polkadot. So I'm glad to be here. I'm going to go ahead and start my screen share, and I'm only going to be speaking for a few minutes. I, in turn, roped our project leader into this so that he could give some of the technical overview of the project, because it's inherently a technical project. So if you can see this, go ahead and nod your head. I want to make sure. Yeah, I should be sharing this. It looks good. Okay. So the name that we gave the project is Kagome, which is in Japanese, it's actually in reference to a crosshatch pattern. And you'll see the logo a little bit later, but connected, everything is connected, decentralized, and interoperability, that kind of a theme. So we went with the name Kagome for that. And I'm just going to give you a quick introduction to Soramitsu and a little bit about the company and what we do and why we started on this project, and then hand it over to Camille to give you a better overview of the project. So Soramitsu is currently, the guys at the top are Makoto Takameya, who founded the company back in 2016. He was born in America, but he's now a naturalized Japanese citizen, no longer American. And he's the CEO and co-founder of the company. And our CTO, the infamous Alish Zivkovic, I never know how to say his name, but Alish is our CTO, and he's the one who asked me to come in and do this for you guys today. So a little bit about Soramitsu. Back in 2016, we started development on a project called Hyperledger IROHA, which is our own blockchain. And that got contributed to the Linux Foundation's Hyperledger project and is now one of the many Hyperledger greenhouse projects. We also have done some really great work with National Bank of Cambodia, which I'll talk about here in a second. And we have a project called D3 Ledger. We're the technology provider to some of the national CSDs in Slovenia and Russia. And we've done an identity project for Bank of Central Asia, which was a proof of concept a couple years back, and we finished that up last year, I believe. And then with a grant from the Web3 Foundation, we did this project, Kagome, for the C++ implementation of Polkadot Host. So a little bit about Hyperledger IROHA. As I said, it's an open source Hyperledger blockchain project. It was accepted into the Hyperledger back in October of 2016. And the point of Hyperledger IROHA, the reason that we built it, was to be simple, fast, and a concentration on mobile and asset management. So we've built things like identity systems and payment systems with it. One of those systems, which is kind of our big project at the moment, you probably read about it in the news, seen some press releases about it, or some articles on CoinDesk or Entrepreneur. Some various places have covered it. It's called Project Bakong, which is a central bank digital currency payment system in the Kingdom of Cambodia, which we built with NBC, the National Bank of Cambodia, the central bank in the country. So that went live in July of last year, and they're about to take the wraps off of a full release of that countrywide in the next month or two. So it's a pretty cool project. And then I don't know why this skipped to slide 6, but that's weird. Oh, it skipped to slide 6 because that's where I was at. Which brings me to the project that we're talking about today, which is the C++ implementation of Polkadot Host. Camille's going to go over most of this for you, but the reasons that we wanted to develop this were obviously to add a new language and expand the accessibility to a wider range of developers. A lot of developers are familiar or know how to code in C++. Hyperledger IROHA was built in C++. Version 2 won't be, but version 1 definitely was. And we wanted to contribute to the security and decentralization of the network, which is obviously a big requirement and thing that Web3 wants for the network. And we wanted to eventually, I'm not sure if it's in there yet, Camille can answer this, but we wanted to also introduce the Polkadot network to Hyperledger IROHA and make it easier for developers to go ahead and utilize Hyperledger IROHA within the network. So broaden the use cases that way. The project was headed up by my colleague, Camille, and his awesome team, which are listed here. And they just finished it up recently and are still in active development on it, I believe. And so I would like to turn over the presentation to be a more technical overview by Camille. Thanks, Camille. Appreciate it. Let me stop sharing.
Okay, let me share the screen now.
Yep.
Okay, hi everyone. Hope you can hear me, you can see me, and can see my screen. Yeah, thanks for the introduction, Taylor. My name is Camille. I'm working for Soramitsu for more than, I think, 2 or 3 years now. So I was initially hired as C++ developer to work on Hyperledger IROHA project, and yeah, I was working there almost from the very beginning. And yeah, after a while, we started this project called Kagome, and I became a team lead there. So yeah, pretty excited working on that, and let me share the details of our project. So I hope you're already familiar with the concept of Polkadot. We have parachains and we have relay chain, which composed of validators who accept the blocks from parachains, well, accept the proof of validity of the blocks and store them. So it's relay chain is very important part of Polkadot, and because of that, it's very important so that we have a very small probability of having bug there, and we have community who is working on this core part of Polkadot. That's why we have several implementations of Polkadot. One of them is based on Substrate. Another is worked by ChainSafe guys called Gossamer, and our implementation is called Kagome. Yeah, before going into that, share how we see blockchains and how Kagome and the general fits this vision. So any blockchain is composed from message queue, which collects any requests or so-called transactions to change the state of the blockchain. It has database, which has the state. It has state transition function, which has the information about how we execute blocks, how we validate transactions, and so on. And we have consensus mechanism. So what is our project and what is Polkadot Host basically? So Polkadot Host is the block. It's not like a blockchain itself. It's rather a framework to creating a new blockchains, and it has this missing part, which is a state transition function. In Polkadot, it is called Runtime, and it has different libraries for managing balances, governance, and so on. So yeah, this part is kind of plugged into Polkadot Host implementations, and yeah, that allows us to get the full blockchain node, which can operate in case of Polkadot, it can operate in relay chain, for example. So this Polkadot Host is composed from WASM interpreter, because WASM is the language which we use to write runtime. It has a consensus layer. Yeah, I'll speak briefly about that later today, and also networking layer. which is made using libp2p. So why we have another implementation on C++? So C++ is quite mature language, and it's one of the most old languages in the world. And funny thing, it's the most popular functional language in the world, because recent versions of C++, they have functional programming paradigms implemented there. So yeah, it's also very performant and allows you to control the memory. It also kind of disadvantage of this language, though, because yeah, you have to be really careful when we use memory management using C++. But yeah, in general, if you can do that, and modern C++ allows you to do that very simply, yeah, you can achieve great performance if you write blockchains using this language. And yeah, that's quite popular language for other blockchain protocols as well. There are like blockchain clients on C++, Ethereum clients, Zcash, I believe. So yeah, basically blockchain community who uses C++ is really huge, and it would be nice to bring them to work on Polkadot, and our project allows them to do that. So this is a brief overview of our project. So we use C++ 17, which is the most recent stable version of C++. Yeah, we use libp2p for networking. I'll explain what's that a little bit later. Yeah, we use Binarian as WASM interpreter. So Binarian was developed by originally by the guys who actually implemented WebAssembly. So it's great that we have this opportunity to use it as we write using C++. Yeah, if you're familiar with C++, you've probably heard of Hunter, which is a dependency management tool. So we support that, and it allows us to, yeah, really integrate new dependencies really easy. We have, yeah, this crypto that listed here, like ED25519. Yeah, we use SHA-256 hashing algorithms and some others as well. Yeah, we also, by the way, have bindings to Polkadot's Schnorkel crypto, because you probably know the rule that you should never implement your own crypto, but yeah, if you can, you should rather reuse existing libraries. So luckily, the Polkadot's cryptography was implemented in Rust language, and it allows us to reuse it, because yeah, using C++, we can create bindings to Rust and reuse some components. So this is exactly what we did to Schnorkel crypto. And yeah, for storage, we use LevelDB, but it's really like a pluggable library, and we can replace it in future with any other storage as well. Yeah, let me give you a brief overview of what is WebAssembly. It's basically a new type of code, and it was initially, when it was created, it was mostly intended to use by browsers. For example, you can write something in C++, then compile it into WebAssembly, and then use it from JavaScript. And now we can basically do the same, but we can write, for example, our runtime, our state transition function for Polkadot in any language like C++, Rust, Java, well, basically any language that supports WebAssembly, and then get the binary and plug it into Polkadot Host implementation. And yeah, basically then you get the blockchain which can execute Polkadot. Yeah, to understand how WebAssembly is working and how we use it in our project, it's important to understand two main concepts: export functions and import functions. Export functions inspect, they are called runtime entries, and yeah, they basically allow you to execute some logic written in WebAssembly from the host language. In our case, it's C++. Yeah, this is like a simple example of that. Like we can have simple add function which sums two numbers implemented in WebAssembly, and we can execute it from C++. Or we can also have import functions which are called inspect runtime APIs. And those functions, they are implemented in host language, and they are being invoked by the WebAssembly code. For example, when we have WebAssembly binary plugged into Polkadot Host, well, this binary itself cannot get access to your storage, networking, or crypto. To extend his functionality, yeah, we need to add these import functions. For example, here we have get value, which goes to storage. And when this function is invoked, we go to our host language, in that case, C++, and execute the get value on our storage. So yeah, with that approach, we can have different implementations of Polkadot Host, and they should basically comply with the Runtime Entries API and Runtime APIs. So yeah, what kind of runtime entries we have in Polkadot Host? We have a version call, which basically returns the version of runtime you are using. You can get authorities, like the nodes, the public keys of the nodes who can participate in consensus. We have, those two runtime entries are the most important ones, in my opinion, like execute block and validate transaction. This is the functions where you describe the logic of how you execute the block and how you verify the validity of transactions. And this is very important to have that in our WebAssembly binary, because you can easily replace that in future if you decide to change your logic. We have the following runtime APIs. This is not the full list. It's much bigger. And I think the names were recently changed because, in reference implementation in Rust, it was also updated. So yeah, it should be updated in our side as well in near future. But yeah, basically we have APIs which allow you to interact with hashes. For example, here you can see Blake2256. You can interact with storage by setting storage, getting storage. That's some information about runtime APIs. And yeah, as I said, this runtime binary is actually stored in our state database by the column code key. And in order to update this runtime, basically update the logic of how you execute blocks, validate transactions, and do some other stuff, you basically need to execute transaction which updates this key value position in the storage. And that's the main idea behind Polkadot, well, one of the main ideas, so that you can have forkless updates without even stopping the network, which is great. The cool story about networking for us, because we didn't have any existing implementation of libp2p library, and Polkadot uses that. So we had several options of what we can do to resolve this issue. One of them was to use bindings over existing Rust implementation of libp2p, and although it's possible, but we decided it's kind of too hard to do and it's hard to maintain, as Rust library also is being updated a lot. So we decided to write our own implementation of libp2p. So what is libp2p? It's basically a network modular stack, and it is used a lot by IPFS, Polkadot, Ethereum 2.0. It is supported by another huge company, Protocol Labs, and by open source community. So what's that? So the main goal of libp2p is to be as modular as possible. So it supports multiple TCP, UDP, quick, and allows you to easily switch between them. It has efficient reuse of this, so that over a single connection you can have several applications working, which is cool. And it has several encrypted channels like TLS. You probably never heard about Sekayo. Sekayo is encryption protocol by Protocol Labs. Also noise. Noise is actually the security protocol that will be used by Polkadot in future. So we will support that as well in our implementation. So you can already find our implementation. It's open source by this link. It's still under development. It's not stable, but it supports a lot of features. We already have Sekayo implemented. We have TCP connections. We have Kademlia for pure discovery implemented. So it's actively being developed. And when we were working on that, we interacted a lot with Protocol Labs. And soon our implementation will be moved to libp2p organization on GitHub. So it basically will make our implementation like official implementation, official C++ implementation of libp2p. Which is cool. From that point, I would like to briefly go over the pipeline of transactions, or how they called in Polkadot, they are called extrinsics. This is kind of more general terms than just transactions. So when, this pipeline starts with RPCs. For RPCs, we use JSON RPC standard, and it operates over HTTP and WebSockets. So that basically you can interact from your browser. You can write curl, or you can write WebSockets frames and interact with the Polkadot nodes, and you can do this with Kagome as well. We have several RPC APIs. We just listed only two of them: extrinsic API and state API, because those are APIs that we already implemented. Extrinsic API allows you to send your extrinsics, then they are being validated, and then they are stored into transaction pool. I will explain in a little why we need transaction pool. And also we have state API, which allows you to get the state. So you have your block ID that you're sending, and with this block ID you identify the state which you are querying, and then you have the key, you query this state and you return the value. We have a lot of other RPCs that we should implement. You can find it by this link. If you know C++ and you want to contribute into Polkadot, this is a great opportunity to you to extend our implementation and help us to be more compatible with Polkadot. Basically, if you have all these APIs implemented, we will be compatible with Polkadot.js, and this is our ultimate target for the near future. Then we have transaction pool. It basically collects transactions and allows you to get ready transactions. Also, transactions, they have so-called tags. Each transaction can provide some tags and also can require some tags. This allows you to basically define some order between transactions. Then when you have all tags provided for certain transactions, it considered as a ready transaction, and then it can be included into future blocks. And for inclusion, and to basically, if you want to create a new block, we need to use Proposer. And the Proposer uses transaction pool, and whenever it is asked to propose basically a new block, it goes into transaction pool, gets all transactions, and then returns the block. That's pretty simple. And here is the interesting part starting, and we'll talk a little bit very briefly about consensus. So we have a Babe mechanism for block production, and it uses VRF, verifiable random functions, to define slot leader. So we have a notion of slots, and for every slot we should understand who is the slot leader. Current version of the Babe, which is described in specification, it's a bit different from the eventual version of Babe, because now we can have like either one block producer, two block producers, or like several block producers, or even no block producers for the single slot. But in future this will be changed, so that for any slot we have some peer who produces the block. Basically this part is implemented in our implementation as well. We can announce blocks when we are slot leader, and then we distribute it and gossip to other peers. As I said before, like we can have situation when we have several slot leader, and because of that we might end up with situation where we have like a block tree, and we have forks with our blocks, and we should understand which block we should finalize. For that, we should understand which block is considered like as a best block, or the block that is the head of the best chain. How it's done in Polkadot, we have, if we have this block tree, we can understand which block was finalized, like the most recent finalized block, and then the chain that contains this block and also the longest chain is considered as the best chain. In this example, you can see that green chain is the best chain, although at the bottom you can see the longer chain, but it's not the best chain because it doesn't have finalized block in that chain. So when we have this best chain, we vote for the best block in this chain. And here comes the grandpa. Grandpa is finalization mechanism in Polkadot and in Kagome. So it's very similar to any other PBFT like consensus algorithms, but instead of voting for blocks, we rather vote for chains. And when we have collected our votes, we can understand which block is considered like the final one. And when we finalize this block, we also finalize the chain that precedes this block. Yeah, that's pretty cool. So yeah, here is our status for today. Basically, using Kagome, you can already set up a syncing node, although it's compatible only with other Kagome nodes because our networking is being actively developed right now. And it's not compatible yet with the Polkadot network, but yeah, it will be really soon. Yeah, we have block production mechanism implemented. So yeah, basically, the initial version of Babe is working, but as I said, there will be another version of Babe, like kind of extension, which has secondary blocks, which allows you to produce blocks on every slot. So yeah, this is work in progress. Yeah, we can have finalization by a single node so that we can set up a network basically where one peer has one peer is validator and it can finalize the blocks. But yeah, because of grandpa catch-up mechanism is not implemented yet, yeah, we cannot set up like several validators, but it also will be implemented really soon. And yeah, the cool feature is that we're already compatible with substrate genesis and substrate transactions. So we can already get some example of substrate node, plug in genesis with the runtime into our implementation, then create transactions and send to Kagome, and yeah, they will be compatible and provide the same, which is cool. Yeah, but we actually learned a lot while implementing C++ implementation of Polkadot Host. We understood that the compatibility should be constantly checked. Like if we use runtime, we should constantly make sure that the way we pass transactions and create blocks is compatible. Any small difference will cause like a lot of efforts in future to fix such bug. Yeah, we understood that we should really have a good knowledge of reference implementation because although there is a spec, but spec is also work in progress. Yeah, we have to refer a lot original implementation, which is in Rust, which is Substrate. So yeah, we kind of read a lot of Substrate code, and we learned Rust pretty good, I think, because of that. And yeah, as I said, the spec is being actively developed, and catching up with it is also a hard task. But yeah, we're doing our best to have compatible implementation of Polkadot in C++. Yeah, that's all from me. So yeah, if you have any questions, we can go to them.
Looks like we had one question that I covered in the beginning, but just in case, he was asking why we named it Kagome, which is again, it's in reference to in Japanese it means crosshatch pattern, and so we liked how that was related to the interoperability of things or the connectedness of all things, and so it was a very appropriate name for the project. Did we lose Carol? I'm not sure what the. Thank you so much, Camille, by the way. That was a really good overview. Appreciate it. If you guys have any questions, Camille, do you have your email address? Did you put that on the screen?
I can share it in chat, I guess, but yeah, you can address me if you like.
Yeah, if you guys have any technical questions, you can certainly email or grab Camille on Telegram. And if you have any questions,
an issue in our repository, it's Soramitsu Kagome in GitHub. So yeah,
oh, that's good too. Yeah, and if you need to reach me for anything, I'm taylor@soramitsu.co.jp. I'll put it in the chat, or you can grab me on Telegram @TaylorMetric.
Great. Thank you so much, Taylor and Camille. I hope you enjoyed this Web3 Builders talk from Soramitsu. Our next one is on Monday next week with Plasm, with Sota and Home from Plasm Network. Yeah, it should be a good one. Hope to see you there. Thanks again and have a great day.
Thank you so much.